So hello everyone. We're Team Superscalar from UC San Diego, and our school is at San Diego, California, and we have team members from all different departments from the school, and we have mentors from San Diego Supercomputing Center and AMD, and also Azure, Microsoft. So now I'm gonna do some introduction about myself, and I'll ask other teammates to do an introduction for them, each of them. So I'm Jacob, and currently I'm a third-year computer science major at UC San Diego, and during this competition, I'm one of the co-lead, and I'm also the lead for the application of reproducibility challenge, MXCT. And yeah, so why not having Max to introduce himself next? Oh, also, wait a second. Let's have Jihao to introduce.
So I'm Zihao, and I'm a third-year computer engineering student. And then in this competition, I'm the co-lead for GrowMax. Yeah, let's do Max.
Hello, I'm Max. I'm a senior computer engineering student at UCSD as well. I'm co-lead for the team and PsychoCloud expert on the team, as well as in charge for the IO500, and ended up with Arunav helping out for the mystery app as well. Arunav?
Cool, I can go next. Hi everyone, my name is Arunav. I'm a second-year student also at UCSD. I study data science as my major. I also study math as my minor. And I led the HPCG benchmark for this competition. Then I also worked with Max on the mystery app. I'll pass it off to Hongyu.
And I'm Hongyu. I'm a senior CS major at UCSD. So in this competition, I'm the lead for HPL. Yeah, I think, yeah, that's pretty much.
We can do mentors next.
Yeah.
Joey?
Oh, hi, I'm Joey. I just graduated from UCSD, and I was helping the team building some useful tools like the monitor things to keep track of the budget. I will pass to Mary Thomas.
I'm Mary Thomas, and I'm the mentor for the project, and I do HPC training. And yes, so let's go to Marty.
Hi, yeah, I'm Marty Kandes. I work in the HPC User Services Group at SDSC, and we were part of the mentor team helping out the students here for their first SC.
Lewis.
Hi, I guess last and hopefully not least, Lewis Carroll with AMD. I'm an HPC Cloud Solutions Architect focusing on the Azure virtual machines that were used in some cases for the competition.
Hi.
Okay, Mahi, introduce yourself.
So I'm Mahidhar Tatineni. I lead the user services group here at SDSC, and I was happy to help out mentoring all the students. It was a great first team at SC. So that's it. Hopefully there are more of these coming down the road.
Okay. So next, I think let's talk about some challenge we encountered during the preparation and during the competition for each application. So I'll start with MXCT. So wait, where's Mahidar? So one of the difficulty for MXCT is that I got to read a very long paper for better understanding on about what is the algorithm the author is trying to do and what are those optimization used for the application. And so in order to get because my challenge to produce a result on the paper, I got to consider I got to think about what kind of machine I'm going to use in order to achieve the same performance. So I think the most challenging part is the tuning part, because I have to adapt the parameters into some of the configuration that's related to my hardware. Yeah, so basically that's it for MXCT, and let's go to the next one for IO500 Max.
Sure, I can talk a little bit. So the IO500 is a file system benchmark that we had to run. And so the challenges associated there were picking the right transfer sizes and making sure that the InfiniBand support we were using built correctly. Interestingly, out of that was, since the IO500 requires the parallel file system and many of the other applications, such as we used it for the mystery app, I think, also required it. It was kind of like a foundational layer. So I ended up also, as a result, becoming the CycleCloud expert, trying to set up these templates to get everyone else up and running, which is always fun getting to work with everyone else here too. Yeah, Zia, do you want to go?
Yeah, okay. So since I'm doing the GrowMax, so one of the I think GrowMax has like two very difficult things. One is to get it to install with the right dependency, such as CUDA, MPI, and then FFTW. So I spent a lot of time figuring how to install with the best options to fit in the virtual machine that I'm running on. So I asked Marty a lot about how to set things up. Also, since CycleCloud is like a cluster, so every compute node does not have GPU driver and CUDA. So also it takes me a lot of time to figure out how to set up everything on the compute node. So when I run GrowMax on compute node, it's gonna be okay. Also, one of the second challenge is that the GrowMax, like before the competition start, I have no idea how long will GrowMax run, because the different input files will lead to different result. So one of the things, because since we are limited on budget, so then I have no idea how long, how much GrowMax will spend. So I sort of just wait for everyone else to finish their project, and then I'll use the rest of the time to run GrowMax, because it turned out that in the competition, the GrowMax takes most long time to run. Yeah.
Continuing on that, I would like to comment that budgeting was actually quite difficult for this competition. Because of the unknown time for, I think it was 2 applications. We did not know how long CESM was going to run or how long GrowMax was going to run. And so we had these 2 big unknowns throughout the entire time. I'm pretty sure everyone here would share the sentiment as well.
Yeah. Yeah, I think budgeting was also really difficult. So for HPCG, I can talk a little bit about how budgeting affected that. Initially, I think we'd budgeted something around somewhere like $100 to $200 for HPCG. The idea was we just do it at the very beginning of the competition, get it over with, and then just work on the applications. But what happened was we used a very heavy CPU sort of cluster to run it in the beginning. We didn't get we thought we got high results, but then UIUC immediately posted results that were 6 times better than ours. And so we realized that it was not good enough, and we had to do another run. This time we used GPUs. And so at this point, we're sort of exceeding over the budget. And that, roughly tripled our score. So it was a little bit better, but still not good enough to, place within HPCG. And at that point, we said, we've spent enough money on HPCG so far. Let's focus on the rest of the applications. And then thankfully, at the very end, we managed to get $500 in extra budget, at which point we were able to rerun HPCG with a much heavier cluster. And then that is what got us into 3rd place for HPCG.
Yay!
Yeah, so I think the same for HPL. So I think it's better to use GPU for HPL. But at first, I'm very into using the AMD HP120 series for HPL. And we tuned everything for it very well. And we got very decent results for single machine, and also it scales very well to multiple machines. But the thing is, in the competition, you have to save money and get a high result. So it's better to use GPU node for HPL. Yeah, But I want to thank Luis and Mahidar gives me lots of help for building and running HPL. Yeah.
Yeah, we can complete all of these challenges without the help from our mentors. So also, yeah, I want to add something more to the MXCT. So because on the CycleCloud platform, the hardware there is kind of weird. So we gotta find MPI processes into the hardware by ourselves. So that's one of the challenge, and that's actually one of the tricks I use to help out Max and Arunav to speed up our mystery apps. So yeah, also I just really want to give a round of applause to our mentors for their help, and yeah.
Yeah, I think all of us were helped by all of the mentors. We really appreciate their help.
Next, talk about some advice for students who want to join the competition next year. So for me, because I work on the MXCT, the reproducibility challenge, I wanted to give some advice on just read the paper as soon as possible and understand how each measurements and how each results are derived. and also read the source code as soon as possible, understand how those output are produced. Yeah, basically. Yeah, let's go to Zihao.
Oh, okay. So since next year, we're not sure if that's going to be virtual or, or physical. So I think my advice is that learn some parallel computing that, kind of lay the foundation for everything in this competition. No matter it's going to be virtual or physical, like some parallel computing knowledge is really useful in terms of understanding things. Even though we don't write code in this competition, but the concept and the knowledge is like very helpful as well.
I would say if there's one thing to look at, it would be learn one instance well if this is a cloud competition in the future. I think that is to be a non-small portion of why we were able to get the mystery application up and running so quickly, is that we had focused in on the HB120, in our case, instances, and we're able to leverage some Jacob's past work here for binding different processes to the level 3 caches and such. To get it running quickly and, to get the application running quickly and to do it in a little amount of time.
Yeah, I can definitely talk a little bit more about that mystery app thing. I would also just add to that, not to underestimate the power of like a simple grid search. I remember Max and I on the second day, we were like sitting down with the Google Sheet and just going through like a series of different parameters, just one by one for the mystery app, and then recording like the outputs for each one, trying to figure out which one was best. And we were running sort of our own little optimization problem there. And I think that really helped us eventually reach the right set of parameters. And then once we did that, we said, okay, now it's time to scale. And so I think that was really valuable. And I feel like just learning how to do that is also really important, because I can really easily see it translate over to any of the benchmarks or even any of the applications. But more specifically to the HPCG, I think it's my lesson learned here is not to underestimate the use of GPUs. Especially with a benchmark like HPCG, which is very vector intensive. Obviously, GPUs do really well with vectors and matrices, and that's a lesson we learned a little bit later on in the competition.
Okay, thank you. Yeah, and I think for the very last question, I actually want to, because I've never asked this before, so I really want to hear from our mentors. So how is your experience during this competition, during the preparation for this competition? And do you have any advice for us that we can improve so that we can do better next year? And
so I'm going to jump out ahead and give one quick answer. I'm just now realizing that this is the first time you guys have done this competition. I thought you guys were professionals at this, so I think that speaks a lot about the team and the support you guys got from from Mary and Marty and Mahidar. It was a pleasure working with you guys. It was a pleasure taking the approach that we all kind of took of learning why you do something, as opposed to just go push this button and see what you get.
Yeah, I'll echo that sentiment. You guys did a great job starting from 0 to 90, like in a month, and then we had to get to 280 or something. So you guys just did an awesome job coalescing, working with each other. I thought that was the most productive part, was watching how you learned to work with each other, even though most of us have never met in person. So you overcame a lot of constraints and barriers there. So I can't wait for next year. It should be a lot of fun. Marty, Mahi? They asked the mentors for advice and guidance. I guess, Mahi, you're next.
So I'm next, okay. Yeah, I mean, from my perspective, it's the first time I'm mentoring a SC student cluster challenge. So that's it's a little bit of learning curve for us too, because trying to figure out all the pieces that go in, and it was fun to watch them get real competitive once they started getting things working, which is, I think, nice, because I think in the end, you have to eke out every little piece of performance you can get out of the hardware. And I think towards the end, they were getting there. They were basically, all the students were, I think, getting into all the optimization pieces. And I can hear her now saying that about the process. And I think what you can learn is for the future competitions is that, yeah, you can get into that mindset right away in terms of optimizing for parameters and everything. Now that you kind of know how to do the baseline setup and compiling and running of applications. So I think you will have a quite a good start for next year. Some of you will be there next year, hopefully, and that'll help.
We will be. Marty?
Yeah, I think the comments you guys made, I'd echo the same. It was, first year, I think it was like a great job. I mean, we all know how many late nights you all put in, and to get this going, and learning just the concepts and the different applications and how to sort of bring it all together as a team at the end. It seems like it worked out really well, and so I'm definitely glad that there's going to be some of you that are going to stick around next year and hopefully bring that sort of energy and knowledge to the team when we start out again next year. Should be great.
Yep.
Thank you.
Thank you.
Yeah.
Thank you. Thanks.
Yes, thank you to all
Yeah.
mentors as well.
And finally, Joey, our graduate student mentor.
What I did is not that impressive. So I basically just write a Python scraping code that can scrape all the data, like all the cost per hour from the Cycle Cloud. And then I store in a CSV file, and then I use JavaScript to generate the plot, and then I finally use the Jekyll template to actually post it on the GitHub page. Yeah,
So
that's pretty much what I do.
Yeah, but Joey, like the other mentors, you were always around. You were often just in on the conversations, and the whole team was that way. So this is my third team, but the first at SDSC. And I think we did very well for a first team, and I'm proud of it and proud of the effort that you guys put into this. It wouldn't have happened without you guys getting in there and doing the programming and the coding. And by the end of it, you were making statements about mapping cores and threads and tasks, and I was having trouble following it. So big kudos to you guys for your big learning curve, and I'm glad that you're already looking forward to seeding the next generation, the next supercomputing student cluster competition team. So well done.
Thank you, Mary.
Yeah, thank you.
Yeah, I want to echo that. Yeah, it was, I think, an amazing job. The first shot. Yeah.
All right.
Definitely.
And very cohesive. I think everyone was helping each other out. That was kind of nice.
And big thanks to Louis from AMD and the amazing support and help you gave. You were always around on Discord and chatting and emailing. So without you, I think your contribution was very significant. So from SDSC and the team, thank you for all the effort you put into it.
You're welcome.
Thank
It
you,
was a
Louis.
pleasure.
Thank you so much.
Thank you.
All right. I think that's for the interview, and I really appreciate everyone for coming and for helping. Yeah. So.
Well, we'll see you guys next year.
Yeah.
Yep.
Next year.
Or maybe sooner.
Or maybe sooner in person.
Hopefully.
Yeah.